Today, we will continue Chapter 4, Chemical Equation and Stoichiometry. Part 2, First Hour, 4.1, Chemical Equation. So 4.1, Chemical Equation, learning outcome. At the end of this topic, students should be able to. So today, we focus to write and balance chemical equation using inspection method. Chemical equations. In this section, we will learn how to write chemical equations and balance them. So, chemical equation uses chemical symbol to show what happened during chemical reaction. Example, consider what happened with hydrogen gas burned in air which contains oxygen to form water. This reaction can be represented by chemical equation, where the plus sign means react with and the arrow means to yield. Thus, this symbolic expression can be read: molecular hydrogen react with molecular oxygen to yield water. The reaction is assumed to proceed from left to right as the arrow indicates. This equation is not complete or balanced. We can balance equation by placing the appropriate coefficient in front of hydrogen and water H2O. Balancing chemical equation. To represent a chemical equation correctly, the equation must be balanced. All balanced chemical equations have the following features. First, a chemical equation represents a chemical reaction using symbols for the reactants and product. Example, symbol A, B for reactant and C, D for product. Next, the formula of reactants are written on the left side of the equation while the products are on the right side. To balance chemical equation, the total number of atoms of each element is the same on both sides in a balanced equation. Next, the numbers X, Y, Z, and W showing the relative number of molecules reacting are called the stoichiometric coefficient. We can balance a chemical equation using inspection method by the following steps. The first step, write down the unbalanced equation. Write the correct formula for the reactants and product. Next, second step, balance the metallic element followed by non-metallic atoms. Third, balance the hydrogen and followed by oxygen atom. Remember, we can change the coefficient but not the subscript. means the number within formula. Changing the subscript would change the identity of the substance. The last step, check to ensure that the total number of atoms of each element is the same on both sides of equation. Example 1. Now let us consider the combustion, that is burning, of the natural gas component ethane C2H6 in oxygen or air, which yield carbon dioxide CO2 and water H2O. So this is an unbalanced equation. We see that the number of atoms is not the same on both sides of the equation for any of the elements, carbon, hydrogen, and oxygen. In addition, carbon and hydrogen appear only once on each side of the equation. Oxygen appears in two compounds on the right side, carbon dioxide and H2O. Let me see two carbon on the left and one carbon on the right. To balance the carbon atom, we place a 2 in front of carbon dioxide. To balance the hydrogen atom, we place a 3 in front of H2O. And this stage, the carbon and hydrogen atom are balanced, but the oxygen atom are not, because there are 7 oxygen on the right hand side and only 2 oxygen atom on the left hand side of the equation. Oxygen atom can be eliminated by writing 7/2 in front of the oxygen on the left hand side. However, we normally prefer to express the coefficient as whole number rather than as fraction. Therefore, we multiply the entire equation by 2 to convert 7/2 to 7. The final value is 4 carbon, 12 hydrogen, and 14 oxygen on both sides. Note that the coefficients used in balancing the last equation are the smallest possible set of whole numbers. Example 2. In example 2, we will continue to practice our equation balancing skill. Here, this equation is unbalanced. All elements, aluminium, hydrogen, sulfur, oxygen, appear only once on each side of the equation. First, we balance polyatomic ion as a unit. Since there are 1 sulfate ion on the left and 3 sulfate ion on the right.
So we can balance the sulfate ion by placing a 3 in front of H2SO4. Then, next, we balance pure element aluminium and hydrogen. To balance aluminium, Al atom, we place 2 in front of El because we have 2 El on the right hand side. And to balance hydrogen, we place 3 in front of H2 because left hand side we have 6 hydrogen atoms, but on the right hand side only 2 hydrogen atoms. As a final check, we can draw up a balance sheet for the reactant and product where indicates the number of atoms of each element. So here, all elements in both sides are same.
Thank you.